Welcome guys, so we keep solving our physics GRE 08774, and we start from 90 we start from 85, and I hope we can somehow try to finish this as soon as possible. So 55 said the particle, okay, so he already give you the wave function. I ask you about, okay, so there are multiple ways to do this. So the first one is we should find a wave function coefficient, and so I suggest that you should remember the wave function. You should remember the wave function in the box, unless you're using it's very easy. Unless you can do integral very quickly. So I will not tell you how to find A, but basically you do the sine square and find A. So basically, this is the answer. Nice. So ask a probability. So it's just 3 squared dx from 0 to not L over 3 by L 2 L 2 times L divided by 3, and this is the answer what we need to do. And then you can calculate by yourself. And but I think the answer is easy. The calculation is easy. So the answer is B. The answer is B. Okay, so let me quickly show the key, some detail. When you do, so this is 2 over L, and when you do the sine square is 3 pi x over L, and then you need to remember this can be written as 6 pi over x, 1 minus cosine divided by half. And when you do this integral, that you see when you put plug L over 3, then this will come out with come with 2 pi, and then this come with 4 pi. So these two actually cancel. So basically, the only remaining is a half. So the answer is just this, right? Because this cosine term vanish, so you are just integral. Your integral function is just 1. So quickly you can get the answer. Okay, so 86. Which of the following are eigenvalues? Oh, come on. This is just the standard linear algebra. Right, so nothing special. Determines 0. So you have this one. Come on. Should be minus 1. This is minus I squared. So so it's minus 1, right? So 2 minus lambda is plus or minus 1. So lambda is 1 or 3. Yes. So the answer is B. The answer is B. By the way, this matrix is Hermitian. So you need to know the eigenvalue for Hermitian must be real. So you can easily delete D and E. Okay. So 87. 87 is an easy question. Why? Because you already tell you the Pauli matrix. So if you see the recent physics GRE, sometimes it did not tell you the form of the Pauli matrix. You need to remember it by yourself. Okay, so you can calculate, but I suggest that you need to remember this, because this is a physics GRE. So physics GRE is somehow depend on the depend on the memory. It should be identity 2 by 2 matrix. So sigma x, sigma y is I sigma z, because this 1, 2, the all remaining is 3. Okay, so the answer is, there should be 2. Right, the answer is 2I sigma z. Sigma z. So the answer is D. The answer is D. Or you can compute. You can directly compute by yourself. But you should remember these two. Okay, 88. Spin particle system is described by this. So basically, okay, you can view just the two-dimensional vector in a complex field, and the probability of finding this one. Okay, come on. So the SZ has 2 eigenvalues, which is this one, and asking about the probability of finding the SZ equals to 1 h bar minus h bar divided by half is just this one. Inner product for this times this one, and do the normalization. Okay. So this one is just this one times this one is 2, and the normalization is 1 plus I bar plus 4 square root. And when you do the inner product, that you should square it. Basically, this computation just find similar as you just similar as you want to find a. So this is 2 plus 4, which is 6. So it's square root of 6 squared. So it's 1/3. Or basically, this is the one way. Okay, the second way is first you can find a. You can denote it that this must be the inner product of this must be 1. Right, and this will tell you that a must be 1 over square root of 6 if a is real. Okay, then you can do the similar computation. Okay, and 89 is the basically you can any textbook have this solution. Basically, you need to set up the differential stuff for the Schrödinger equation and then match the boundary condition. But actually, you should remember that. So this is the this is the refraction coefficient, and the reason is that suppose K2 is equal to K1, then there should be no reaction. Suppose K2 is equal to K1, there's no relationship. There's no reflection. So you know that when K2 equals K1, then R should be 0. So this is the phenomenon that you should remember. So you can actually guess the form, because in the real exam you don't have time to do the computation. So at least you know when K2 equals K1, then there's effectively no barrier. So you know that there should be no reflections. So the answer is D. The answer is D. You can go to check any quantum mechanics book and the computation. But the problem is in the subject GRE, each problem you can only take 2 minutes. So you don't have time to do the derivation. So you need to somehow remember the answer or use some physical intuition like K2 equals to K1. There will be no reflections to tell you the answer. So the answer is D. The answer is D. Okay, 90, and basically you have two thin concentrated sphere. Basically, you should use the Gauss law to help you to find the Gauss law to help you to find the electric field, and after that you can do the integration. Okay, then solve then you can solve the nth problem. This is also easy. Okay, let me do it for you. If this is plus Q, this is minus Q, then the electric field here is 0, right? Because when you do we'll draw a Gauss series, then there's nothing. And then you can draw here. So here is basically the Q divided by 4 pi epsilon naught R squared. And here is also 0. So this is from infinity is 0. So it takes so this one is 0, right? So and the outer potential is also 0. So at the infinity, you know that the answer is 0. But this depends on which one will you set. Because in this question it did not tell you that which one is the which point is the potential should be 0. So this question, what you need to do is you can assume that this is 0 and 0 0 0. The second is still 0, and then you do the 1. So basically, suppose here in the region 1, V of R minus V of A, is equals minus v of b should be rb and q over 4 pi epsilon not r squared dr, and this is 0. I can assume that it's 0, although it didn't tell me the answer correct immediately. Okay, and this is the one, and the second is in this region is the same. So what we solve is in the second part is this is 0 and this is q over 4 pi epsilon naught r1 over r1 1 over b. Okay, and the amazing thing is that when you see the choice, there's no this kind of answer, because actually we don't know what is the potential ground. But all we know is the first region minus second region, the potential difference should be fixed. So actually this is the criterion what we have. So we can check the first one. Region 1 minus region 2 is not this. Region 1 minus region 2 is 1 over r minus 1 over a, which is not this. And then this one minus this one is not this, because 1 over r can become 2 over r. But the d is important, right? 1 over r minus 1 over a minus 1 over b plus 1 over a. So d choice, the region 1 minus region 2 is the same as this. Okay, so this tells us the answer is the answer D. So this problem is tricky, that because usually I will set the infinite points, the infinite far away points has potential 0, and I do the integration from the second region to the first region. But in this problem, it did not tell you which point. So the only thing you can know is use the first minus the second. The potential difference must be constant to get the answer. So this problem is very somehow quite difficult, or quite tricky. 91 basically ask about the common sense of Maxwell equation. So I guess you already know the EBJ rho means. So which of the following condition allows us to write this? Which one? I think it's the least one, right? Because curl rho add-on gradient is 0. It's 0, so you can at least locally write E equals to this. So the answer is C. This is just common sense. Nothing special. Okay, I think up to here is okay for this video. I will see you guys in the next time. And be sure to subscribe to my channel.